And so the practice IVIVC, it says, we said in class, this is explained in the slides, okay? What does it mean? A level B and a point by point that would be a level A, all right? So here, I'm gonna give you a let's go back here, right? So I give you, I pretend that somebody, they did already the basic, all right, of the IVIVC. So we have the dissolution and the 0, 1, okay, the absorption rate constant, and then if we plot them, okay, we should get a straight line, all right? So now we're gonna have, so actually why I did that, you can copy all of it, all right? And then you're gonna do your formulation that you'll be your test formulation, all right? And you have to find K01 and the K dissolution. I think, so we're gonna add no project, all right? Oh, we already, and then we're gonna have a worksheet, and we add a column that we call time dissolution. Okay, and then we have another column that is called dissolution. And then let's see, what are the unit here? I have it here. The unit are milligram per liter and hours. Oh, sorry, milligram. Yeah, milligram, right. So the time, I forgot to put, so this will be hour, and the dissolution is in milligram. Okay? So what I'm gonna do is, I have to find the K dissolution. So I'm gonna send this to Winolin Classic dissolution model, and then I'm gonna fit the best model, all right? I have the Hill and the Weebull. Did you find the explanation of these two models?
The Weebull is good.
The Weebull is good, yes. So you already did it. So let's say we try the Weebull, all right? So the initial estimate, I think you don't have to do it, and the unit, I think you just go. Okay, and you find the mean dissolution time. The only thing you have to remember is the relationship between, the K dissolution is equal 1 over the mean dissolution time, all right? And then you have the oral data. Doesn't matter, I'm not going to do again. You do the same thing we did. You fit with Winolin, you find the K01. Okay? So once you find the two numbers, okay, let's say that you find 0.44, okay, and 0.38. So what you do, you're gonna go in the plot, all right? So first of all, here you can add the trend line. And then I want to. All right, okay. And then you're gonna go into this graph, and then you're gonna go in. Select data, you can add a series, all right? And your x will be this one, and your y will be this one, all right? And this is coming, all right? So when you do this, all right, you can tell that if, for example, I just invented, all right, this is not, so you can tell that this is a little bit off, all right? So it's also off. Then you can use the equation you have to predict. So this case this would be your x and this would be your y, all right? So what would be the predicted, all right? The predicted would be equal to 0.6748 that multiply this one plus 0.2436. Okay, so you can, this would be the predicted, all right? So this would be the predicted. So you can calculate the percentage error. The percentage error will be equal to the observed minus the predicted, then I don't, divided by the predicted or the observed.
No.
The predicted multiplied by 100. So this is minus 18%. So this would be a little bit on borderline. They say up to 20% would be acceptable. I don't remember. 10% would be ideal. Less than 10%. 20% would, so this one will still be acceptable. Okay?
هي تتخبط
This is clear. And then when you do,
على النقطة
when I
المطالعة
ask
كده
you to
بين
do the level
الميديوم
A, you have to
الميديوم
do
ولا
the deconvolution. And the deconvolution, now I don't want to go all together, all right? But when, you know, let's say that you have this data set and you send to the deconvolution, is not here, you have the possibility to select. So when you do, because when you have your data set, all right, you see that the data for the IV, for the PO, are different from the sampling time for the dissolution, all right? So you have the possibility to do the deconvolution, and with the deconvolution you find the in vivo dissolution process, all right? You have the possibility to predict at the same time of the dissolution sampling. So at this point, you're going to have a column with the predicted in vivo dissolution. If they are predicted at the same time, you can plot the dose release, all right? It's not, oh, you're right, this is not a concept. No, this is the amount. Yes, the dose is an amount, but the concentration is the dissolution, I think. Or you do the amount to dissolve. Yeah, okay, sorry. All right, and then you can compare. Can you see? You know, if you have 1-to-1, you know, if you have a straight line, it's good. If it's not so good. All right. Is it clear to everybody? Any questions?
deconvolution
All
جدا
right,
لما
so that's all.